Hello guys, welcome to the Python series. In today's video, we're going to look into decimal module. The decimal module provides support for fast, correctly rounded decimal floating point arithmetic. It also offers several conventional advantages of the float data type. So decimal is based on a floating point model which was designed with people in mind and necessarily a principle that computers must provide an arithmetic that works in the same way as the arithmetic that people learn at school. So a decimal number is immutable. It has a sign, coefficient digits, and also an exponent. To preserve significance, the coefficient digits do not truncate trailing zeros. Decimal also includes special values such as infinity, minus infinity, and NaN, which stand for not a number. The standard also differentiates from a minus 0 to plus 0, and the examples we have tried out in today's video is going to be, and some of them are square root function, exponential function, natural logarithm function, log to the base 10 function, compare function, FMA, which stands for fuse, multiply, and add function, as tuple function, copy, ABS function, max and minimum function. So now let's do some examples on the decimal module. First, in order to start off, let us import the decimal module. Then the first function we're going to look in is the square root function. So a is equal to decimal dot decimal. So we have 2.5 dot square root. So we're going to print saying that the square root number is, so here you can see that the square root of the given decimal number is 1.58. Next we have b. Next we are going to find the exponent of the given function. This function returns the exponent in the exponent of the decimal. So we have d, which is nothing but the decimal dot decimal. The same uh, decimal, we're going to take it as 2.5 and we're just going to use the dot exponent function, and we're going to print saying that the exponent for the given decimal number is, and we're going to say b, and you can see that the exponent for the given decimal number is 12.1824 for the given decimal number, which is 2.5. So the next function we're going to see is the natural logarithm. So decimal dot, so here in this case we're going to pass in the e component or Euler's number, which is represented by 2.71828, which will give you, when you take the log of that number, you would get the output as 1. So in this case, let us check it out by using the natural logarithm, and I'm going to print natural logarithm of the given number is, and we're gonna say c. So here you can see that the natural logarithm of the given number is 0.999327, which is almost approximately equal to 1. So this is what you get for decimal. The next we have is dot decimal. We're gonna next for function we're gonna try is the decimal for the logarithm 10, log 10, and we're gonna take 10, so that would give you the output as 1. The logarithm base 10 value of the number 10 is 1. So let's check it out. So here you can see that logarithm base 10 for the given number, as you have seen already, that logarithm base 10 for the given decimal. Here in this case it's taken as 10, so the output for this statement would be 1. So the next function we're going to see is as tuple. So here in this case we're going to take a minus sign before our given decimal number and check out the as tuple for the following decimal. So here in this case it's gonna print this decimal number as tuple containing 3 arguments. It's gonna print a tuple containing 3 arguments and an exponent. So here let's print it out. So here the tuple containing 3 arguments and exponent is, so the decimal tuple here in this case it's a 1 positive sign, so 0 for positive and 1 for negative. So if the decimal contains a negative sign, it's going to give the sign to be 1, and if it's a positive decimal number, so the sign would be 0. So let us try that out. So let us remove this negative sign and just print it again. So here you can see that the sign is 0 in this case for the positive decimal number, and the digits is 2.2 comma 5, which is 2 and 5, and the exponent would be -1. So the next function we're going to use is FMA. So FMA stands for fused multiply and add. So in this case let us send a decimal here and dot FMA, let's say 2 comma 3, right? So here what actually FMA is, that it is nothing but fused multiply and. So suppose you have arguments, 3 arguments, so you have A, B and C, so it is A into B plus C. So this is what actually FMA is, that first it actually multiplies the first 2 arguments and then adds on with the third. So here it is 5 into 2 plus 3. So let's try that out. So when we print the FMA for the given decimal number, so here in this case is F is, so here you can see it's 13 because 5 into 2 is 10 plus 3 is 13. The next function we're going to try is the compare function. We're going to compare the two decimal numbers. So first decimal we're going to take for comparison is 5.3, and the next decimal number we're going to take is, let's say, 5.8. So we're going to print if the first decimal argument is greater than the second, it's going to print a 1, and if the second one is, if the first argument is seen to be lesser than the second argument, second decimal number, or h in this case, so it is g dot compare h. So if g turns up being less than h, then it would print a -1 or a -1. So if g is greater than h, or let us interchange, as in this case h is greater than g, so let's interchange and check it out. So here in this case you can see that the output stands out 1. So the next is compare total magnitude. It's going to compare the total magnitude of the decimal number. Returns 1 if the first argument is greater than second. In similar case, it just compares the total magnitude of it. So we have g dot compare then total magnitude of h. So here in this case is -1. It's same. It's almost same as compare, just that it takes up the total magnitude of the given. So next we are going to look in the function is copy ABS. So let's check that out. So we have h dot copy ABS. What it does is it prints absolute value of the given decimal argument. Suppose let's have h. So it's prints out the absolute value of the given argument. So it's like absolute value is close to 5.8. So it's going to print a value which is very close to the absolute value 5.8. So next one we have is next function we have is negate, copy dot negate. So what this does, it gives the negation of the given decimal argument. So for h, it's going to give the negation of that particular argument. So it's nothing but the negative of the given argument. So here it's the actual decimal is 5.8. It's going to give you the negation of it, which is minus 5.8. The next function we're going to see is print a dot max of g. What we're checking is we are checking with a. So we are here we have a, which is decimal of 2.5. So let me change this. Let's remove square root, and we're just gonna print a here. So it's gonna be 2.5. What you're gonna see is we check out which is maximum. So whether a is maximum or g is maximum, it's going to print out the maximum value among a and g. It's going to compare between a and g, and it's going to print the maximum value between those. So here you can see that here of course g is going to be maximum because it's 5.3. 5.3 is a greater decimal number in comparison with 2.5. So it's going to print g to be maximum. Then let's check out for minimum also. So when you try for minimum, it's going to print the value 2.5. So because 2.5 is less than 5.3.